So basically when you have graphs like this, sometimes the graph can be like this, it can be like this, or like this. So to determine whether these graphs are for functions or not, we need to do what we call the vertical line test. So we do, for example, the first one, we do the vertical line test. Is this a function or not?
This is a function.
Why is it a function?
Because when you cross the vertical line, it's only one answer of on the x-axis, x value.
That's right. So
let me bring up. It's either one value of x values or all x or y values.
that's right. So basically, you do this is what we call the vertical line test. If it meets the
For the x.
Yes. If it has to be vertical, not horizontal. If it meets only once, it's a function. It has to meet only once. Okay. But if you do and it cuts more than once, is that a function?
No, it is not, because
right,
it meets points.
That's right, not a function, because it meets twice.
So that's only what we have to say. It is not a function because the vertical test doesn't succeed. It has 2 points.
That's right. So
it's a good.
So this just only says we'll ask you to decide whether it's a function or not. And it may ask you to find the domain or range. If it asks you to find the domain and range, then you do that. For example, this one, let's say, maybe like this. So let's say, for example, maybe some
infinity.
-5. And let's say here maybe 3. And maybe I got -4 here. So let's find the domain and range of this function in interval notation. So what is the domain? The domain is the values of what variable?
Yeah.
So the domain, what's the domain here? Domain usually is the values of what variable?
Y and x and y.
So the domain itself is for the values of x. So this is the x, this is the y.
And y.
So for this graph, what is the domain? In other words, the values of x, they go from where to where?
From 7 to -5 to 7.
That's right.
And 3 to -4 to 3.
That's right. So the domain is this. It's basically just the values of x. As you can see, from -5 all the way to 7. That's the domain. So this is the values of x. So we can write this in interval notation from -5 to 7. But do we use brackets or parentheses around the numbers here? Start with the -5. It has a circle here. That means it's not included. If it's not included, we use parentheses because of this circle. But this one is shaded. If it's shaded, we use brackets. That means it's included in that number. Okay? So the domain is -5 all the way to 7, but not including the 5. We skip it. We go to the next number. But here, we do include the 7. It is part of the domain of the function because of this point. It's continuous. It's not discontinuous. Okay? It doesn't have a hole in it. Here we don't include it, but here we do not include the -5, but we include 7. So the domain is the values of x. What about the range? The values of what?
Now -4 and 3.
That's right. The domain is basically the values of y. So the lowest y possible for the graph comes from here. So the range goes from here all the way to where?
To 3.
To 3, basically here. So all the y values are included in this interval. So this is the y values, anywhere from -4 to 3. So -4 to 3.
Professor, in my homework.
When you do the interval notation, you want to start with the smaller number first. Smaller number on the left, then the right number. So now Is the -4 included or not? Is -4 included?
This is included.
Included, that's right. That's right, because we don't have a circle. So that's
No
included.
circle.
No,
Use bracket or
the
parentheses?
graph is not.
Do we use a bracket or parentheses for -4?
It's supposed to include it's a bracket.
Right.
It's a circle. It's a bracket. It's a bracket.
Right? Bracket. What about 3 here? So 3 is here. Is that 3 included or not? Is 3?
It includes.
Include. Unless you see a hole here. We don't have a hole in the graph. It's continuous. This one here is down here. It's not 3. It's not 3. It's probably 2 here. So it's not here. So basically we take this, we drop it over the y. So this is continuous. That means it's included. Okay, so we use a bracket here. We use a bracket because it's included. Okay, does that make sense?
Yes.
So that's how you get the domain and range from a graph. Is this one a function? Is this one a function?
Yes, it is.
No, this one.
No,
Yes.
this is not function because when you put the vertical lines, you have 2 points, which is on the x-axis. Professor, I will try to clarify this. I mean, this is a vertical line, right? You're drawing, right?
Mhm.
Can it be on the horizontal line as well?
It can be no. So to determine whether it's a function or not, we do the vertical line test.
Only vertical line.
Yeah, so this is not a function. Okay. To determine whether it's a function or not, we do the vertical line test. Not this.
I thought we do the horizontal line as well. No.
So we do the horizontal line only to determine whether it's 1-to-1.
Oh, okay. All right. Thank you.
So when we determine whether it's 1-to-1, for example, this function, if it says, is this 1-to-1, you have to do this test like this. So this is not a 1-to-1 because it meets twice. It is a function. If you do the vertical line test, it is a function because it meets vertically only once. But to determine whether it's 1-to-1, you do the vertical line test. So this is not a 1-to-1. It is a function, but not 1-to-1.
Yeah.
Okay, so the vertical one to determine whether it's a function or not. The horizontal one to determine whether it's a 1-to-1. So, for example, this one, is this a function?
Yes.
So this one is a function. Let me make it a little bit like this. So it is a function because only meets once, right? Vertically. But is it 1-to-1 if you do the horizontal test?
No.
No, because if you do the horizontal test, it will meet here and here. It will be a
No.
function. It's a function, but not a 1-to-1 function. Okay, so that's how you determine the domain and range from the graph. It's easier. You can just read it from the graph itself. And okay, so this was part of the domain and functions unit. Let me take your attendance. Any other questions, please have them ready as I take the attendance.